Hello, I'm Bruce Dickinson, and I'm here in this video to tell you why your loading of an aircraft can make a real difference to flight safety. So let's start with the basics. Aircraft loading. Well, first of all, you need an aircraft and you need load. What is load? Well, load is everything that goes on the airplane. Passengers, freight, cargo, bags, tea and sandwiches, even your duty free. And together, that load makes up something called the weight and balance of the aircraft. What is weight and balance? Well, it's the weight that goes on the aircraft and it's the balance of the aircraft after you've finished putting all that load onto the aeroplane. It's very important it's done correctly, but the best way to see it work in action is to go down to the actual ramp itself. And this young lady here is going to help me. In fact, they've given me my very own baggage tag. So as self-loading freight in the truest sense of the word, I'm about to go down and see how loading takes place. Ready? 3, 2, 1. Right, always wanted to do that. Now then, I'm now officially a piece of self-loading freight. I am now going to become part of the weight and balance of an aeroplane. This aeroplane. Typically, there are three main areas where you can distribute load on an aircraft. Doesn't matter whether it's a passenger aircraft or a cargo aircraft. There's the whole of the upper deck. There's a cargo area behind the wing, and there's another one forward of the wing. Anywhere you put load in any of these locations will affect the centre of gravity and the trim of the aircraft.
Every type and series of aircraft has its own specified safe flight envelope, as set by the manufacturer. And every flight envelope has its own specified maximum and minimum limits for both weight and balance. To ensure that control and stability is maintained during all phases of flight, aircraft must be operated within the flight envelope. To achieve that safe condition, the effect of the weight and balance must be calculated, the result of which is called the centre of gravity, the C of G. To influence the position of the C of G, load is positioned forward and aft of a central balance point. Everything put forward of that point will move the C of G forward, and everything put aft will move it rearward. The final position of the C of G will determine the horizontal stabilizer trim setting. So, starting with an empty aircraft, watch and see how load affects the C of G as it is added. First, the fuel, followed by a full load of passengers. Then we add a typical standard baggage load. That gives us a fairly normal C of G, nicely within the safe flight envelope, good to go. However, if an aircraft were partially or incorrectly loaded with an excess of load in the front, this could happen. And if there were excess in the rear, this could be the result. Finally, undeclared or too much load may do this. Whilst aircraft are able to handle various weight and balance conditions, they must be within all limits before departure. So, to ensure safety is not compromised, it's vital that everybody involved is aware of these restrictions and understands that seemingly minor changes to the load may put the aircraft outside of its envelope.
Right, so now we've covered the science bit, come with me and let's take a look at how we can load this particular aircraft, starting with the upper deck. As a passenger, my location on the aircraft can make a real difference to the aircraft's centre of gravity. In fact, I'm changing the centre of gravity on this Boeing 747 simply by walking up and down the aisle. But my seating position can also make a real difference. For example, here, or here, or here. Just remember, on average, every person sitting on board an aircraft weighs the equivalent of 7 passenger bags down in the hold.
So, from a cabin crew perspective, whether you're operating an allocated or free seating flight, be aware of passengers playing musical chairs after the doors have been closed. If they move, the C of G will change.
Exactly the same goes for the lower holds or any compartments which are not part of the main passenger compartment. Most airlines have a preferred loading system which ensures that the centre of gravity always remains within acceptable limits. All aircraft holds are further broken up into compartments. Doesn't matter whether they're bulk loaded or container loaded. And within those compartments, there's a specified distribution. Now, it could be specified as
100 bags in here and 80 bags in there, or even baggage containers in the front, cargo pallets in the rear. Whatever the planned distribution is, the aircraft must be loaded in accordance with that plan. If it isn't, a gross error may have fatal consequences.
Even if a loading error doesn't put the aircraft outside of its centre of gravity envelope, there's a very good chance it will put the aircraft into a situation where it's difficult to control. Good way of demonstrating this: step inside this car with me, I'll show you. Aircraft control surfaces are absolutely enormous, but even at this slow speed, just with my hand, I can feel an appreciable force that changes as the angle changes in the airflow. Now imagine the kind of forces on these aircraft control surfaces at speeds of 150, 200, 300 miles an hour. It's critical that the information given to the pilot is the correct information in order to set the control surfaces.
When the flight crew receives the load information, they will adjust the horizontal stabilizer trim setting to the correct trim. That way, the aircraft will handle as expected on takeoff.
Tiring being an airplane out there, isn't it? Now, when takeoff speeds and power settings are calculated for an aircraft, they're based on how much the aircraft weighs. How do you find that? Well, you look on something called the load sheet. Who makes a load sheet? Well, the Load Control Office makes a load sheet, and those are these good people right here. Welcome to a typical Load Control Office. Morning! Morning! Here is a typical load sheet. It contains vital information about the weight and balance of the aircraft. It's extremely important that the calculations on this document are cross-checked for accuracy. In an extreme situation, if they're in error, the aircraft may not even take off at all.
In the flight deck, crews can also play their part. When you receive the load information, take time to read the figures. Don't just take it for granted that they are correct. Use all of the information available to you to ensure that a gross error has not been made.
Whoever's responsible for the load control function will also provide one of these, a loading instruction report. And it's important that if you sign the certification block on this, you make sure that the aircraft is loaded in accordance with the instructions. And if there's any deviations, you record them on here. Now then, in addition to that, double check that if it says airplane's empty, that the holds are in fact empty. Obviously, different types of aeroplanes are loaded in different sorts of ways. You wouldn't expect a Boeing 757, for example, to be loaded in exactly the same way as an Airbus A320. However, what's not so obvious is that even within the same type of aircraft, you can load it many different ways, depending upon the operator and where it's going to be going. So always check before you load that aeroplane exactly how the operator wants it to be loaded. Now, if the load is not adequately secured, strapped or locked, there could be trouble. Moving that around in here at 37,000 feet could damage the pressure hull of the aircraft. Definitely not recommended. Alternatively, moving a big load around in here can also change the center of gravity of the aircraft, the C of G, and that could lead to control difficulties or even loss of control.
So before you leave the hold, make sure that all loads have been secured, strapped and locked down.
How strapped and locked down? Well, strapped and locked down to up to 9 times its own weight. That would make me 3/4 of a ton. That's a baby elephant. Now, if dangerous goods are carried aboard the aircraft, it's important, one, they're labelled correctly, they are securely stowed, and they're stowed the right way up. In addition, something called a NOTOC, a notification to the captain, is going to be given, and that's going to be given up there.
Dangerous goods must be packed, loaded and secured in the proper manner. Otherwise, they may become a danger to the aircraft and everyone on board. Before loading, always inspect packages for any evidence of leakage or damage. Whether dangerous goods are to be containerized or bulk loaded, they must be secured to prevent any movement and also be protected from being damaged by the movement of other load on board. That could either be within a volumetrically full ULD or compartment, or secured individually. Oh, and remember, the arrows always point up. The NOTOC contains several items of vital information. That's because if there is an incident, everyone involved, from the flight crew to the emergency services, are aware of the substances that they're dealing with and where they've been loaded on the aircraft. This document must also show confirmation from the person responsible for loading the aircraft that there was no evidence of damage or leakage from the consignment. Special loads, like these for example, have their own specific loading requirements. So always make sure that you've been provided with the proper equipment before attempting to load and secure them. In addition, electric wheelchairs or mobility aids powered by either non-spillable or lithium-type batteries must be protected from inadvertent operation, short circuit or damage caused by the movement of baggage or cargo. Prior to loading, make sure that the device has been fully deactivated. Disconnecting or removing the battery is not required, since this can be very difficult to do and, if not done properly, can increase the risk of a fire. If that is the only option, in order to immobilize the device, make sure the battery is protected against short circuit by insulating the exposed terminals. In 2008, ground staff offloading a passenger aircraft noticed blue sparks coming from a battery-powered wheelchair. It was quickly removed onto the baggage belt, where it immediately burst into flames and was destroyed. The electric circuit had not been protected from operation, and during flight, baggage probably moved the joystick control, engaging the motor. The subsequent friction or electrical load ignited the wheelchair.
Well, hello again and welcome to Oxford Flight Simulator 001. You've already seen what happens when an airplane is loaded significantly out of trim in an aft direction earlier on in the program. What we're going to do now is try and experiment with loading the airplane out of trim in the forward sense. I can tell you without too much deep thought that it's going to cause some unexpected handling difficulties.
The start of the takeoff run is completely standard. We're departing from a shorter runway, but that wouldn't normally be a problem. Everything is going as expected until we try to rotate the aircraft. Very quickly, it becomes apparent that it will not leave the ground. So we attempt to stop the aircraft and overrun the runway at high speed. Out of curiosity, we then put the aircraft excessively out of aft trim. Note the warning lights and alarms as we become airborne,
It's going on here.
but not for long.
It just took itself off. Okay, hang on, full thrust, that's no use. Okay, you can. Give me a hand on the nose, get the nose down. 70 degrees nose up. Okay, airspeed, speed, trying to correct. Through the vertical now. Push, push, okay. Try and put some rudder. Put some rudder on it.
It's not looking particularly
Okay, fine. Okay, bang. Our industry has many time operational problems, restrictions, delays. We're always in a hurry, we're always under pressure. But there are three simple things that we can all do to make safety our number one priority. And safety is and should always be our number one priority. First of all, there's a plan. How to load the aeroplane. Follow that plan. Secondly, if things do not go according to plan, tell somebody. If you think that the load is unsafe, if you think that it's more than it should be, don't just accept it. Ask and tell somebody. And thirdly, and very importantly, any loads you do put on an aircraft should be secure. Make sure the load is secure. Make sure the locks are in place. Make sure it's strapped down and it will not move under the stresses and strains of flight. If you do find any errors, even after the airplane has departed, tell someone as soon as you possibly can. That information may be vital to impart to the flight crew, and it may determine whether or not they have to do a diversion or alter their flight plan in some way. This has been a short film, but hopefully it's given you an insight into the degree of accuracy required to make every flight a safe flight in terms of loading the aircraft. We're waiting for passengers now. Let's not let them down. Let's make sure that every flight is a safe flight. Mind how you go.